Look at this. This is the Nvidia H100. For the last few years, it has been the king of the world.
It powers ChatGPT. It generates your Midjourney images.
And it made Nvidia the most valuable company on Earth. But there is a massive problem hiding in plain sight. This architecture, it's hitting a dead end. We are running out of power, we are running out of cooling, and we are approaching the limit of what silicon can actually do. But in a lab, quietly, a new challenger has appeared. It doesn't calculate like a computer. It thinks like a brain. Say goodbye to the GPU and say hello to the neuromorphic chip. To understand why the GPU is dying, we have to look at how computers have been built for 70 years. It's called the von Neumann architecture, and it works like this. You have a worker, the CPU, and a library, the memory. Every time the CPU wants to do anything, it has to walk to the library, get a book, and walk back. Get data, process data, put data back. This creates a traffic jam called the von Neumann Bottleneck. And with modern AI, that traffic jam is a nightmare. An AI model like GPT-4 isn't just reading one book. It's reading the entire library, thousands of times a second. All that moving back and forth wastes 90% of the energy. Not on thinking, but on just moving data. This is why data centers are drinking our water reservoirs. And why your top-tier graphics card doubles as a space heater. We can keep making the chips smaller, but we can't fix the physics. The distance is the enemy. Unless we stop building computers like machines and start building them like this. The human brain is the most complex computer in the known universe. It has 86 billion neurons and trillions of synapses. Yet, it runs on just 20 watts of power. That is less energy than a dim light bulb. How? Because the brain doesn't have a traffic jam. In your head, memory and processing happen in the exact same place. The neuron stores the memory, and the neuron makes the decision. This is neuromorphic computing. Instead of moving data across a city, the data talks to its neighbor. Immediate, efficient. Companies like Intel with Lohi and startups like SNNs are actually building this. They aren't using logic gates, they are using synthetic neurons. But the hardware is only half the magic. The real revolution is the spike. See, a normal AI, like the one running on your GPU, is like a fire hose. It processes everything, every single frame, every single millisecond. Even if nothing is happening, the GPU is burning power to check that nothing is happening. Neuromorphic chips use spiking neural networks. It only fires a signal, a spike, when something changes. If nothing moves, the chip consumes literally zero energy. It's called event-based processing. We humans think in logic, linear steps, A, then B, then C. But spiking networks are chaotic. They are noise. It was impossible to write software for them. But recently, we stopped trying to write the code ourselves. We started using standard AI to convert itself into spiking AI. And suddenly, the impossible became possible. Now the applications are terrifying. First stop, robotics. Current robots need to talk to the cloud to be smart. That means lag. With neuromorphic chips, the brain is in the robot. It reacts in microseconds, faster than a human pilot. Next, space exploration. It takes 20 minutes for a signal to reach Mars. If a rover sees a cliff, it can't ask NASA for help. It dies. Neuromorphic chips give it survival instincts. No lag, no NASA. And finally, you.
prosthetics, and brain-computer interfaces.
Because these chips speak the language of spikes.
They can talk directly to your nervous system.
Restoring sight to the blind? That's not sci-fi anymore. It's a bandwidth problem. We are moving from the era of cloud AI to the era of edge AI. The GPU isn't going to disappear overnight. It's still great for training.
But for running AI? For the devices in your pocket?
The brute force approach is over. We don't need more power. We need smarter power. We need to stop building calculators and start growing brains. The next computer revolution won't happen in a giant data center. It will happen right here, in the palm of your hand. And Nvidia, they better adapt fast. Because nature had the perfect architecture all along. Thanks for watching.